So next for this example, we're going to consider how to copy. So now if we're thinking about like a unary number, like it's 0, 0, what it means to copy is to take what is here and concatenate it with itself. So this would be, for example, a copy of what is here. So what I want to do is take the input, I want to concatenate it with itself, creating a copy, doubling the length of the string. So that's what we're going to be trying to do here. So let us design a Turing machine that takes the input, and concatenates a copy of the input. So just to give you an idea of what we're assuming, the numbers are in unary. They're in unary, separated by a marker. The form assumed is 0 to the m, where m is greater or equal to 0. That means it's going to be the number 0 in unary. It could be the number 1, number 2, number 3, number 4, number 5. It could be any non-negative integer represented in unary. So if you think about it, the way I would describe this, it should be 0 to the m concatenated with 0 to the m. That's what I should look for. Now, I'm going to show you a technique. This technique is rather valuable when you think about Turing machines, okay? Because you start having to remember things. And remembering things can be a little tricky if you're not aware of a very simple way of pairing things. Because sometimes when you're counting, it's unclear, okay, do I have the same number of objects, or do I have a bigger set of objects on one side versus another side? Now, what we could do is we could use a very simple technique of pairing elements to count them. And that's actually what we're going to do with our Turing machine. So, for example, you know that this is correct because I can pair this one with that one. I can pair this one with this one, right? That's how I know that I did it correctly, right? But you'll notice it gets kind of hard for me to tell the difference between this group of symbols and that group of symbols as I'm doing this, right? So you're going to see that I'm going to have to be a bit careful about this. So here's an idea. Seeing as it's an example about copying, maybe an interesting idea. So here's an idea. Here's an idea. So we're going to convert all the zeros to a symbol C. So we're going to call it C. Then go left to see the first encountered C and change it to a 0 and immediately that's supposed to say immediately, by the way. It's supposed to say immediately. It sort of melted over there. It was having a dream and it kind of woke up a little too fast. And then immediately adds a 0 on the rightmost end. So let me walk you through what I'm saying. Okay. So over here, I was like, okay, well, you kind of pair them, right? Well, think about it this way. So you start off with 2 zeros. That's the input. Okay, so what I'm suggesting is, instead of having zeros, turn them into C's. And then what you're going to do is, now it doesn't technically matter which of the C's we go for first. We're just going to go with the first encountered one. What we do is we change the C into a 0. And because I encountered a C, that means I need to pair it with a 0. So what I do is I go right, I put a 0, because that pairs it up with one C. Then I go back and try to find another C. I replace that C with a 0. But because I found a C, that means I need to pair it. So I end up with a 0. Hence I get 4 zeros. That's the idea. And this technique, by the way, is colloquially called zigzagging. Okay? Some people call it zigzagging. So some people call it zigzagging, or they're performing a zigzag. So the idea is that you pair elements to try to see if you can find another one. And the minute you can't pair them properly, something needs to happen. So here we go. So now if we have, has everybody got the idea? The idea is I'm just going to try pairing elements after I've presumed I haven't counted or paired them yet. So every time I find another 0, I'm going to add another 0 onto the end on the right. And until I no longer have any C's left. So what we're going to do is we're going to consider a Turing machine. We'll call it tcopy. Tcopy will have 4 states. Now, I want you to think carefully about this. First, what we did, the idea we have up here, is we start off with just by replacing the zeros with C's in the input. That dictates needing a state. Next, we start doing the zigzagging, right? We start going back this way to find a C. So we need something to do that. And maybe we need another state for copying the 0 on the end, like when I took and paired it off. Then I need something to tell me when I'm done. That seems pretty reasonable, right? That seems pretty reasonable. So let's go with that. So we're going to call it Q0. That's the start state. We'll also kind of colloquially call it Q0 because it replaces the zeros. We'll have QS for search, QE for add to the end, and QF for when we're done. The input symbols, we just have zeros, nothing interesting. Tape symbols, we're going to have 0, C, and the blank symbol. We're going to have the transition function. We're going to have Q0 as the start state, and then we have the blank symbol. So remember, a transducer has 1, 2, 3, 4, 5, 6. Six of these guys, not 7. It's a 6 tuple, not a 7 tuple, because we don't have final states. Where delta is defined by the below transition table. So we're going to need a table. I'm going to do one just because these get a little bit more complicated. What I'm going to do is I'm going to, again, so I have states. I don't get any 4 of, I'm going to probably have 4 of them. This is just me kind of brainstorming as we're kind of doing it together here. I have 0, C, B, and then I'm going to have a description. So let's kind of walk through what we had in our heads. So we're going to replace all zeros with C, well, C's. So that's kind of what we want Q0 to do, right? So that's what we need Q0 to do. So let's see. So if we see a 0, we better turn it into a C. So we're going to stay in the state. We'll go right. If we see a 0, we replace. So we stay in the same state. We replace zeros with C's, and we go right. See, we don't have any C's at this stage that we're going to encounter. Once we see a blank, that means we've hit all the way to the right, meaning that we can now start this pairing process by zigzagging. So we have QS, blank, left. So if I go all the way to the right on my tape, like when I had the 0, 0 that I replaced with the C's, there'll be a blank right here. I want to make sure I put the tape back to be right here. Let's start the head, the tape head. Sorry, I'm getting really excited. So I have Q0. So now we're going to search for a C. That's the job of this next state. Now, question. When do we finish this searching process? We do it when we hit a C, but what if there is no more C's? That's when we want to end the process of this and means that we're done because we're done pairing them, right? That's what we said when we were kind of playing around with our little example over there. So let's play around with this now. You most certainly want to make sure that we want to hit a C, but we might run over some zeros while we're there. So let's make sure we stay in this searching state. We leave the zeros as they are, and we continue going left if we see a 0. If we see a C, that means we now need to pair it off. So we're going to go into that go to the end, add a 0 state. So I'm going to replace the C with a 0 because now I've counted it. We're going to go right. And I'll start us on that process. If it is a blank, however, we know we're done, right? We didn't find a C. We failed to find a C, so that means we need to wrap this up. So we go QF, blank, and left. So now that we have our task for which we're searching for C, now if we're successful at finding C, we will be in QE. So that means we're going to stay in QE. If we see a 0, we'll go right. We're going to pass over any zeros. However, we're not going to run into any C's because we're going to do this until we hit the first C. However, when we see a blank, we better replace that with a 0. So we're going to go back to the search phase and try to find us another C, because now I'm going to append that 0 on the end where a blank is. And I go left. So this will copy 0 to the end. And naturally, what's the last row going to look like? It's not very interesting. The row's not very interesting. QF is just going to have, we're not going to define these, and we're just going to halt. Boom. So there we go. There we go. So now we can see how we can use the zigzag technique to copy data on the input tape. And like I said, you can actually take the idea that we have, even though it's the unary here, it's not very hard to take and adapt this idea to copy more generalized data. It's all based on the zigzagging idea and having enough symbols such that you could represent each one, so that when you could keep track of the data that you're copying over. Pretty neat, right?